Hey, good morning, all you cool cats and kittens. Mr. C here, checking in with you this week on April the 6th. Please don't forget that we will have science material for you today on Monday and again on Friday, so look out for that. And Wednesday, I'll check in to see how things are going as well. Hopefully, you are able to join us today at 10 o'clock and again at 10:30 for a GimKit session. Here's the class code for the first one, and the second one I'll make directly after we run the first session. Also, please make sure today that you follow the link below for Skate Park Basics. I'm going to open it up here to do it. Click on the link, the play button here. Well, again, we're going to go into the playground where we can actually create our own skate park. Now, you can be as creative as you like here or as you don't like. It's really up to you. I'm going to try to do something like this on mine. We'll see how this goes. Now we're going to turn on the bar graph. It's going to graph the amount of energy here. Notice it has kinetic, potential, thermal, and total. It's hard to see the total with the way I got this set up. That's what we're going to do, is kind of measure and monitor how the energy transfers. We're going to take our little skateboarder here. As you see, the higher you get, the more potential it gets, more gravity potential energy we get. Also, our total energy goes up as we raise it. So we're going to start this skateboarder off right here. I'm going to let go. See, that's not too bad. Crash and burn. But if you notice, as our skateboarder is going up and down, the kinetic, potential, and thermal is changing. Now, if we take friction down to none, let's see how that affects thermal energy. Ooh, a little dangerous. But you can design your own skate park, kind of play around with it, see what you can make it do, and watch the energy go back and forth here. Remember, notice here the total energy stays the same throughout. Alright, cool. Next, we're going to have a Forms of Energy T-Notes. For the T-Notes, please use workbook pages 115 and 119. The Forms of Energy T-Notes looks a little something like this. Link to it. Make sure after you've made a copy of it, you share it with your teacher. That's me. And you're going to submit the link to it. I've even went as far here to color code it and tell you which page to find the answers from. Seems fairly easy, I believe. Hopefully you guys can figure that out. I have faith in you. Back to our calendar here. We also have a discussion question here. It's due before 3 p.m. on Friday, so have a look at that. And then here is kind of like a living document. If you follow this link, start a question thread, please use a format like this. So, for instance, I put my first name and last initial. I have a question on the slide. What I will do for you is, I'll be checking it all day. I'll come in here, and I'll write Mr. C, and I will answer your question. If you could, please don't mess with other people's posts on here. So, again, I'm going to try to get to this as quick as I can, so please be patient with me. I think this way, if you have a question and somebody else has the same question, I won't have to answer the same thing over and over again through email. This way we can all see it. Alright, cool. If there's any questions, please don't hesitate to email me if that's what you're comfortable with, or go ahead and enter that doc. Hopefully, a lot of you will be able to go to the GimKit session today. Have a good one.